Good morning, guys. Hopefully everybody's doing well today. If we can start with some green check marks, please, then we'll get started. As well, if anybody had any questions from the learning guide, I know we took a bit of a break because of the midterm last week. I haven't seen you guys for a full week. But if you did have any questions, then you could throw them on into chat, and I'd be happy to go through those. If not, we'll just keep on moving. And today I hope to finish up Unit 3. This last section in Unit 3 it's definitely a tricky one. So I would like you guys to have lots of time to look at it. So in terms of sort of timing, obviously we're done Unit 1 and 2. So we're on Unit 3. Today we're going to do this Applications of Exponent Laws Lesson 4. And you're not really going to learn anything new. All of the exponent laws we've covered are all just essentially put into one section, and you just do problems that involve all of the exponent laws at one time. So it's a bit tricky. And I'd like you guys to be able to finish up the learning guide for next class, and then have that Unit 3 test written sometime before next Tuesday is kind of my goal. So whatever that means for you and your time frame and schedule, then there you go. Nobody had any questions from the learning guide Unit 3? I guess if nobody has any questions, then nobody has any questions. All right, let's jump into the last thing we did was, I believe it was in lesson 2. No, lesson 3. No. This was in Unit 3, Lesson 2. There was a couple questions at the bottom of the page, and I said, oh, we'd come back to these. And I never came back to them, and then we had the midterm, and I wanted to look at them now. So this is Unit 3, Lesson number 2 from the lessons. And if you scroll to the very bottom of the page, I left these 5 questions for us to do. So I'd like to go through those first, and then I'll go into lesson 4, and we'll finish off this unit. So this is kind of, it's tricky because it's a little bit of grade 9 and a little bit of grade 10, and it just kind of gets mixed together. But we have an exponent on the outside of our brackets, and we're asked to evaluate. So if you remember this exponent law, a to the m, and then you have a bracket and then an n, you multiply your exponents. That is a little bit different. This is where students get really confused. If I had a to the power of 2 times a to the power of 3, what would I do with those? Well, I would add my exponents. I would get a to the 2 plus 3, which is a to the 5. So how is this different than this? What makes those two things different? In one case, I have exponents with the same base, and I'm multiplying these things together. In the other example here, I have one base and exponents on either side of the brackets. So in the first example, I multiply my exponents together. In the second example here, I add them together. So this is why this section is so difficult, because you're taking all of these laws that you're supposed to know, and they all get piled into one lesson. And you have to remember what to do when. And there's no necessarily correct order to do these things in. You can kind of just do them in whatever order you want. But it's just a matter of kind of getting used to the questions and figuring out the easiest way to do it. So we're going to look at this law right here. And it says that anything inside my brackets gets the exponent. So what I'm going to do is I'm going to give the 2 to this 10, and I'm going to give the 2 to this 2. So I'm going to get 10 squared and x to the 2 times 2. So everything inside the brackets gets the exponent. If I had 3 things inside my brackets, all 3 of those things would get the exponent. If I had 5 things inside, they would all get the exponent. If I had a fraction with numerator and denominator, they all get the exponent. If it's on the outside of the brackets, it has to act on everything inside of the brackets. 10 squared is 100, and x to the power of 2 times 2 is 4. So that's what we end up with there. The second example, we have a 3 out front and then a bunch of stuff inside the brackets. And we kind of go through our order of operations. So anything in terms of brackets, exponents, division, multiplication, addition, subtraction. BEDMAS. I look at my brackets. Do I have anything inside of my brackets I can do? No, I have x, a y, and a z, so I can't simplify anything in there. So brackets is done. Next thing is exponents. I'm just going to drop this 3 down. And then everything inside of my bracket is going to get this exponent of 3 outside. So I'm going to get negative 2 to the power of 3. I'm going to get x to the power of 3 times 3. I'm going to get y to the power of 3 times 3. I'm going to get z to the power of 2 times 3. So I've given everything inside my brackets that exponent of 3 that was on the outside. All right, so this 3 out front stays there. Negative 2 times negative 2 is negative, or positive 4 times negative 2 is negative 8. X to the 3 times 3 is 9. Y to the 3 times 3 is 9. And Z 2 times 3 is 6. Now I could multiply this 3 through everything inside the brackets. I still can, I suppose. 3 times 8 is going to give me 3 times 8. It's going to be negative 24, x9, y9, z6. So that's as simple as that fella gets. All right, these last 3 are a bit trickier again. Nothing too terrible though. Same principles apply to what we just looked at, except now we have fractions to deal with. So as I said before, if it's on the top, it gets the exponent. If it's on the bottom, it gets the exponent. Everything needs to get the exponent. If I follow BEDMAS, I'm going to simplify anything inside my brackets. So let's do our simplification first, and then we can actually work on this exponent of a 3 on the outside second. The first thing I'm looking at here is the 16 divided by 8. I know that 16 divided by 8 is 2. The next thing I'm going to look at is this a to the 4 on top and a to the 2 on the bottom. Now if I had a to the 4 over a to the 2, we know that when we divide radicals, we subtract our exponents. So that's a to the 4 minus 2. So that's what I'm just going to do, a to the 4 minus 2. The next thing I have is this b. And again, I'm dividing, so I'm going to subtract my exponents. I still have the 3 on the outside. That hasn't changed anything. All right, so I have 2. I have a to the 4 minus 2 is 2. B to the 4 minus 3 is 1. I don't have to write it in, but I can. And I still have this 3 on the outside. So everything inside the brackets needs to receive the 3. So that's going to be a 3, it's going to be a 2 times a 3, and a 1 times a 3. So I can get 2 to the power of 3. I'm going to get a to the 2 times 3, and b to the 1 times 3. Pardon me. 2 cubed is 8. 8 to the 2 times 3 is 6. B to the 1 times 3 is 3. The next one here, same thing. Now we have a negative exponent. So we need to deal with it in any way we want. We could deal with that negative exponent first. We could simplify inside the brackets first. Whatever you want. Now, because I've done a few of these and I look at it and I say, well, I have a negative exponent, and if that fraction was flipped, it would make simplifying it a lot easier. Well, that's what I'm going to do first. There's no, necessarily right or wrong way to do these. So what I'm going to do is I'm going to write down the same fraction, except I'm going to take the reciprocal. And that gets rid of my negative. So this goes from -2 to +2. And because I flipped my fraction, it becomes positive. Now I can simplify everything inside the brackets. 25 divided by 5 is going to give me 5, and then I'm going to have x to the 5 minus 2. Because I am dividing, I subtract my exponents. I get 5x cubed and both things inside of my bracket get the exponent of 2. 5 times 5 is going to give me 25. I guess I can do it in 2 steps. 5 squared, and then x to the 3 times 2. 5 squared is 25, and 3 times 2 is going to give me 6. All right, this last one is the same principles we've been dealing with, nothing new, except we have a negative exponent on the outside of our brackets, and then we have negative exponents inside of our brackets. So we're just going to treat it the exact same way as we did the previous question. So the first thing I'm going to do is I'm going to get rid of the exponent on the outside of my brackets with that -3. So I'm going to flip everything. I'm going to get 12x to the -2 on the top, divided by 4x to the -3 on the bottom. Now everything has a positive exponent. I've taken the reciprocal of everything. Okay, I have 12 over 4, and 12 divided by 4 is going to give me 3. And then I have x to the -2, and I know when I divide fractions, I subtract my exponents, as long as they have the same base. Now it looks really, really confusing, but it's not terribly bad. I have 3x to the -2, and then I'm going to subtract -3. X to the power of -2 minus -3 is kind of like x to the -2 plus 3, so I get x to the power of 1. Then I get 3 cubed and x to the 1 times 3. End up with 27x cubed. All right, how do we feel about that? Happy, sad, angry, confused? Put it into chat, let me know. They do require some practice. You will need to do a few of them before it kind of clicks. And I guess the trickiest bit of it is that you can do it different ways. There's no you know, I could have done the simplification inside the brackets first, and then I could have dealt with the exponent outside. One person's with me. Perfect. All right, let's keep going. If nobody has anything to say, let's do lesson 4. I promise you it'll get easier once you do a few examples. The learning guide does a pretty good job of kind of starting fairly basic and then getting a little more complex. All right, we're going to start by writing down all of our exponent laws because we're going to use them all. None of these are new. You've dealt with these in grade 9 and again in grade 10, but it kind of helps to just summarize them all, and that way we can refer back to them if needed. The first one, product of powers, looks like this. If I had a to the power of m times a to the power of n, I am going to get a to the power of m plus n. So if I'm multiplying with the same base, I add my exponents. A to the power of m over a to the power of n. If I'm dividing same base, I get a to the m minus n. I subtract my exponents. So those ones are pretty straightforward. You've done lots of examples with those. Now we have power of a power. So we had a to the power of m times n. So we got an exponent on the outside of our brackets. We get a to the m times n. Power of a product, let's go a times b to the power of m is a to the power of m, b to the power of m. So everything inside my bracket gets my exponent. And power of a quotient is the exact same thing. A divided by b to the m is a to the m over b to the m. So those are the exponent laws. You need to know them. They're not on your formula sheet. You have looked at them in the past. I believe in grade 9 you're introduced to at least the first 2. We did stuff with some negative exponents, rational exponents. That would be the new material for grade 10. So let's mosey on down into this first question here, and we'll see how we do. It's just more of what we were just doing. So what's the value of all of that in the brackets when a is -3 and b is 2? Sorry that didn't copy very well. Just make sure I get the right exponents. I believe this is a to the power of 5, b to the power of 2, so the 3, no, let's go with this. A to the power of 6, b to the power of 2, a to the power of 3, b to the power of 8? I think that's what that says. Six, 9 bombs, 5, 8. Is that 9? All right. Thanks, Eric. All right, all to the power of -2. So I guess there's 2 things going on here. I could substitute these values in for a and b right away if I wanted, but I don't. I want to simplify first. Oh, b to the 8. So just like I did before, I really don't like dealing with these negative exponents. So I want to simplify before I do anything in terms of substituting those values in. I don't like this negative exponent here. I want to get rid of it. So what I'm going to do is I'm going to flip everything. I'm going to get a to the 5 on top, b to the 8 on top, my numerator, a to the 6, b to the 9 on the bottom. But at least now my exponent on the outside is positive. That's why I want to simplify that. All right, if I had a fraction like a to the 5 over b to the, a to the 6, like that, I have 5 a's on top, I have 6 on the bottom. If I cancel those all out, I'm left with 1. And remember, when I have something that looks like e to the 5, that's really 5 a's. 1, 2, 3, 4, 5, and 6 a's on the bottom. 1, 2, 3, 4, 5, 6. So if I start canceling these, a divided by a is 1, 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 and I'm left with 1a on the bottom. So when I have something like a to the 5 over a to the 6, it just leaves 1a on the bottom. Same thing with b to the 8 over b to the 9. That's just going to leave a b on the bottom. So if I simplify inside my brackets here, I'm going to end up with a 1 on the top. a to the 5 and a to the 6 is going to give me 1a on the bottom. And the same thing with my b's. I'm going to end up with 1b on the bottom. Just going to move this up here. Now I have this 2 on the outside, and if we look up above here, it said that if we have an exponent on the outside of our brackets, everything inside the brackets gets that exponent. So I have to give the exponent of 2 to everything. So I'm going to get 1 squared, I'm going to get a squared, and b squared. So 1 squared is 1, a squared is a squared, b squared is b squared. I'm just going to rewrite it again up here. 1 over a squared b squared. Now, if I go back to the initial question, it says that a is negative 3 and b is positive 2. So anywhere there's an a, I'm going to put in a negative 3. Anywhere there's a b, I'm going to put in a 2. Still have 1 on the top. 3 times 3 is 9. 2 times 2 is 4. 9 times 4 is 36. So I've shown a lot of steps there. You don't necessarily need to show all of them. But that is just something that we can do. Kind of show everything when you're going through it. If you can work through it a little bit faster in your head and can do a couple steps at a time, I'm okay with that. All right, we can use the exponent laws to simplify expressions that contain rational number bases. It's convention to write simplified powers with a positive exponent. What does that mean? It means that we'll never have negative exponents in our answers. They'll always have positive exponents, never negative. Kind of like we never have a radical in a denominator. Same sort of mathematical principle. Okay, Simplifying, you'll notice that these all are essentially the same base. If I wanted to write this as x to the negative 3 times x to the 5, I could. It doesn't really much matter. I'm going to leave it as 0.3 just because that's what it is. Now, we're trying to write these things as a single power, so we're going to use all of our exponent laws to kind of simplify them down. Now, I'm multiplying these things together, and I know when I multiply, I add my exponents. So I'm going to get 0.3, and I'm going to take this negative 3, and I'm going to add it to 5. Negative 3 plus 5 is 2, and 0.3 times 2 is 0.09, not 0.3 times 2, 0.3 squared, sorry. The next one's similar type thing. We have the same base. We have exponents on the outside of our brackets. We actually have double parentheses, which doesn't really mean much other than just kind of preserve the negative sign in there. So the first thing I'm going to do is I'm going to deal with my exponents on the outside of my brackets. I could get rid of this negative exponent first if I wanted, but I think just to keep it simple, I'm going to multiply these together and these together. So I'm going to get negative 3 over 2 to the power of negative 8 times negative 3 over 2 to the power of 6. So that is my first step, exponents on the outside of my brackets. Power of a power. Now I'm multiplying these things together. When I multiply exponents with the same base, in this case my base is negative 3 over 2, I add my exponents if I go up to the top. Same base, I add my exponents. So power, or product of powers, that's what I'm dealing with. Negative 8 plus 6. Negative 8 plus 6 gives me negative 2. And kind of round out of room here. Negative 3 over 2 to the power of negative 2. I want to get rid of my negative exponent. In order to do that, I am going to take the reciprocal. And one thing that I always do is I leave my negative sign on the top. Some people will say, well, Mr. Borden, the 3 was negative, not the 2. Well, it doesn't really matter if the negative sign's on the top, the bottom, out front. I just always write my negative on the top. This is just a habit that I've gotten into over the years. You can leave it with the 3 if you want. It won't much matter. Now, this is all squared, so I did forget my brackets here and here. Negative 2 to the power of 2 over 3 to the power of 2 is going to give me positive 4 over 9. And I guess the important thing here, right here, is we must get rid of negative exponents. Right there. So we can't have negative exponents in our answers. All right, there are 2 questions, C and D. I would like you guys to have a go, see how you do. Same bases for both examples. The laws don't change, so just be confident in the laws of exponents and see what you end up with. I'll give you, I don't know, just a minute or something, and you guys can plug away at those. Letter D does require a few steps, but letter C isn't comparable. So have a go. I'll put up an answer here in a second. All right, for both C and D, you should end up with the base 1.4 and then in D 7 to an exponent. Is anyone brave enough to put in their the answer they got for C? So just the exponent you got for 1.4. Anyone get an answer? At the end, you should have something like 1.4 to the power of, that's what we're looking for. No dice. All right. 1.4 to the 3 plus 4 over 1.4 to the negative 2. I could do it this way. And I get 1.4 to the power of 7 over 1.4 to the power of negative 2. And then I could subtract. I go 1.4 to the power of 7 minus negative 2, and I get 1.4 to the power of 9. So that's one way to do it. I could have done it this way. I could have gone, okay, I have a negative exponent here on the bottom. If I bring it to the top, it becomes positive. So I'd have 1.4 to the power of 3 times 1.4 to the power of 4 times 1.4 to the power of 2. And then I end up 1.43 plus 4 plus 2 is 1.4 to the 9. That's another way to do the question. That would be fine as well. There's no right way to do it. You could do it in the black or you could do it the blue. Whatever kind of makes the most sense to you, just do it that way. I'm going to get rid of this for a second. All right, this next one is similar to the one we just did. We have fractions though. And as soon as students see fractions, they panic. No, fractions, so scary. They're not scary. You guys know how to add and subtract fractions. You've been doing it for years. Just be confident in what you're doing and you'll be fine. So 7 to the power of 2 over 3. On the bottom I have 7 to the 1 over 3. And I'm multiplying it, so I'm going to add my exponents. I have 7 to the power of 2 over 3 on the top. And 1 over 3 plus 5 over 3 is 7 to the power of 6 over 3. Now, as soon as you see 6 over 3, you're like, well, I should simplify that. 6 over 3 is 2. You're right. You could simplify it, but you're going to have to kind of unsimplify it because when we add or subtract fractions, oh, sorry, I forgot the 6 on the outside. When we add or subtract fractions, we have to have the same base. And I see that I have a 7 on the top and a 7 on the bottom. And if I am dividing, I can subtract my exponents. So I'm going to have 7 to the power of 2 over 3 minus 6 over 3. Because I am dividing, I can subtract my exponents. 2 minus 6 is going to be 7 to the power of negative 4 over 3, all to the power of 6. Negative 4 over 3, and I'm going to multiply by my exponent of 6, which is really 6 over 1. So I'm going to get 7 to the power of negative 24 over 3. Uh, 24 divided by 3 is going to give me negative 8. And I know I can't leave my answer as a negative, so I have 1 over 7 to the power of 8. Jenna, this is the Unit 3, Lesson 4, Applying Exponent Laws page. So as you can see there, we can throw curveballs at you, but the laws stay the same. The process is the same. If you have same base, you add your exponents. If you're multiplying, if you're dividing, you subtract your exponents. It doesn't matter if they're whole numbers or fractions, adding, subtracting, multiplying, the laws still apply. Sometimes you're dealing with fractions, sometimes you won't be dealing with fractions. Generally speaking though, the questions always kind of work out nicely. They're all designed to work out. So don't look at it and get all afraid. There's lots of stuff going on. It's going to work out. You just got to have faith in the exponent laws and just go. Just do the problem, pick a step and do it. Once you've done that step, pick the next step, do it. Just keep going until there's no steps or no simplification left. All right, so the only difference these questions have as opposed to the previous questions is these now just have more than one variable. So they have an x and a y or an a and a b, as opposed to before we just had one base. So in the last question it was 7, the one before that was 1.4. Now we just have a's and b's. But it's important to remember that the laws don't change. When I multiply exponents, and they have the same base, I add my exponents. And that is exactly what we're going to do here. I notice that I have a 3 and a 2 with my x's and a 2 and a negative 4 with my y's. So because I have the same base, I can add my exponents. I'm multiplying. If this question looked like x to the 3 times x to the 2, I'm sure most of you would just say, oh, that's easy. X to the 3 plus 2 is x to the 5, and you'd be done. Well, just because I put the x next to a y doesn't change that fact. So what I'm going to do is just exactly that. I'm going to have x to the 3 plus 2 and y to the 2 plus negative 4. X to the 3 plus 2 is 5. Y to the 2 plus negative 4 is y to the negative 2. I know I can't have negative exponents in my answer. In order to make this positive, I'm going to have to flip it. 1 over y to the 2. These are being multiplied. So it's just going to equal x to the 5 over y squared. Letter B is like the ones we started with at the beginning, at the end of lesson 2. Same sort of idea. I've got 10 and a 2 I need to divide. I have 5 and a 2 for my A's. I have a 2 and a negative 2 and a 3 for my B's. just going to do what I did before. 10 divided by 2 is going to give me 5. With my a's, I have a to the power of 5, and because I'm dividing, I'm going to subtract my exponents. So 5 minus 2. I'm going to do the same with my b's, 3 minus negative 2. 5 stays a 5. 5 minus 2 gives me 3. And then b to the 3 minus negative 2 is going to give me 5. All right, 4 more questions. And these have reintroduced our fractional exponents or rational exponents. The process doesn't change though. It's the same thing. All right, if I have an exponent outside of my brackets, I need to multiply that by the exponents inside of the brackets. And remember, next to the 8, although there is nothing there, there's always a 1. So I'm going to end up with 8 to the power of 1 over 3. 3 times 1 over 3 for my a, and b is going to give me 6 times 1 over 3. Does anybody remember what 8 to the power of 1 over 3 equals, or how I could simplify that any further? Three times 1 over 3 is going to give me a to the 3 over 3, and this is going to give me b to the 6 over 3. 8 to the 1/3. Nobody remembers that? That's too bad, because that's pretty straightforward. That is the cube root of 8. Flowers the power, roots the root. The cube root of 8, of course, is 2. All right, a to the 3 divided by 3 is just 1. I don't need to write it in. And then b to the 6 over 3 is going to give me 2. This next one is almost identical to the question that we did up above. This guy here, 2a. X to the 3, y to the 2, x squared, y to the negative 4. All I did was I added my exponents with the same base. That's what I'm going to do here. 3 over 2 plus 1 over 2 for my x, and my y is going to be 2 plus negative 1. Three over 2 plus 1 over 2 is going to be 4 over 2. 2 plus negative 1, I guess I could put that in brackets. 2 minus 1 is 1. X to the 4 over 2, 4 divided by 2. I don't have to write in the exponent 1, so I could just leave it like that. Now, letters C and D is kind of where the rubber meets the road. The beauty of questions like this is I can test your ability to do the entire unit in one question. Some of these questions can have literally every exponent law kind of hidden in them. So we need to decide what we want to do first. Now, so far I've just kind of picked my whole numbers or my integers, dealt with them, dealt with my a's, dealt with my b's. That's what I've done so far, and that's what I'll continue to do. Get rid of those. So, 4 divided by 2 gives me 2. A to the negative 2 divided by 2 is a to the negative 2 minus 2. Just dividing, I subtract my exponents. Then I have b to the 2 over 3 minus 1 over 3. I know I can't have negative exponents in my answer, so I need to deal with that. The 2 will stay on the top. Instead of multiplying it by a to the negative 4, I'm going to multiply it by 1 over a to the 4. And then I'm going to have b to the 1 over 3. To just make this a little bit prettier, I'm going to think about it like this. 2 over 1 times 1 over a to the 4 times b to the third over 1. Multiply my tops. You get 2 b to the 1/3 divided by a to the power of 4. All right, last question. I could do it different ways. I could first deal with my exponent on the outside of the brackets, multiply it through everything. I could simplify inside the brackets first if I wanted. Doesn't really matter how you do it. You just need to pick a kind of a way and just go for it. What I will probably do is this. Maybe I'll simplify what's inside of the brackets first. Might be a good way to do it. So I have 100 on the top and 25 on the bottom. 100 divided by 25 is going to give me 4. I have a to the power of 1 on the top and a to the power of negative 5 on the bottom. So it's going to give me a to the power of 1 minus 5. And then I don't have anything to simplify this b with, so I'm just going to leave b to the negative 1/2 on the bottom. All right, I have my power of half, I have this 4, I have a to the 1 minus 5 is negative 4, and then b to the negative 1/2 on the bottom. All right, now the next thing I could do is get rid of my negative exponents by flipping those things, switching them. Or I could deal with the 1/2 on the outside. Doesn't really matter. Maybe I'll deal with the 1/2 on the outside now. The 1/2 goes and gets multiplied by each of these things. Rewrite it up here. 4 to the power of 1/2 now. A to the power of negative 4 times 1/2. And on the bottom I have b to the negative 1/2 times 1/2. Let's do the multiplication. 4 to the half, negative 4 times a half is going to be negative 2. And a half times a half is going to be negative a quarter. All right, 4 to the power of a half is going to be same thing as 2, because 4 to the half is the square root of 4. My a is negative on the top, so I'm going to move it to the bottom, and it's going to become positive, so a squared. And my b was negative on the bottom. If I move it to the top, it becomes positive. So I get 2b to the quarter a squared on the bottom. All right, does anybody have any questions there? Anything that I did was confusing, steps you missed, didn't understand, exponent laws you don't get, anything at all? Going once, going twice. I'm going to just jump over to the learning guide. Yeah, this stuff is hard. I'm not going to lie. Generally speaking, this will probably be the section that students don't do very well in. Not to say that you can't do well in it. I mean, it is just a lot. So when we left before the midterm, I said you should end here. So that leaves about 4 pages of the learning guide to go through for next day. Now, you'll see the learning guide starts pretty straightforward, and then it kind of gets trickier and trickier and trickier. These first few questions just ask you to get rid of negative exponents. This is the bottom of page 6 out of your learning guide. Number 8, 9. Simplify, so leave with only positive exponents, a little more straightforward. Finding the reciprocal, negative exponents. And then number 13 kind of looks like the questions we just did with these really complex things with lots of x and y's. But you need to just kind of plug away at them. Rational exponents, so these are kind of your fraction exponents type questions. Right in radical form, so converting between exponents and fractions, flowers, power, roots, the root idea. Go through those. Exponents, applications of exponents is kind of what we just did. So there is a few questions to go through. The hardest ones are going to be on page 7. Number 13, C and D, obviously those have a lot of steps involved. We do have a few minutes here, so what I'm going to do is I can put up maybe 15 minutes. Yeah, we'll put up 15-minute timer. Let you guys try some of these questions. Maybe just pick hard ones or pick the ones you know how to do. It doesn't really matter to me. In 15 minutes, come back and ask some questions. If you run into problems on things, it can be really from anything on this entire learning guide, Unit 3, and just see how you do. It's going to just take some practice, you getting familiar with exponent laws. If it helps, I will recommend that you guys keep out at the very top of today's lesson, lesson 4, there was this little summary of all of the exponent laws. If it helps to keep that out, then keep it out. And you can say, okay, if I'm multiplying powers, I add. If I'm dividing, I subtract. If I have powers and powers, you know, everything inside the bracket gets it. Things like that. So I'm going to leave you there. 15 minutes. We'll come back. If you have questions, let me know. Go through as much as you can, and we'll see how you guys end up. So good luck. Thanks. All right, guys. Sorry my image isn't up right now. Did you have any questions you wanted to go through? Oh, we got another 10-minute timer. Anything you ran into trouble? Anything you didn't understand? Anything that looked really fun? 10C. Brilliant. Do you want to throw in a page number, Leads? Thank you. Page 6. There is no 10C on my page 6. I have 9C. Is that what you meant down here, this guy? Unless you have a different page 6 than me. No. I don't know what no means. This is my page 6. I don't see a 10. Sometimes the pages get renumbered when you download them. First thing on your page 7. This guy. Okay, perfect. Thanks, Eric and Leeds. Combined effort on that one. Simplify and leave with only positive exponents. Okay, you can do that. Again, there's many different ways to do a problem like this. There's no way that's any more correct than the other. The first thing I notice is I have an exponent on the outside of my exponent. So what I'm going to do is I'm going to give each thing inside the bracket that exponent. So I'm going to get 3 to the power of 2, and then x to the negative 3 times 2. And this y to the negative 3 on the bottom doesn't receive that exponent because it wasn't inside the brackets. So just to continue on here, I'm going to get 3 squared x to the negative 6 and y to the negative 3. Now, I could write these things as separate fractions. I could write it as 3 squared times 1 over y to the negative 3 times x to the negative 6 over 1. I could write it like that and then flip everything. Bring my y to the 3 to the top, and then my x to the negative 6 would become x to the positive 6 on the bottom. Or I can just move these things around. So I could say, okay, this is negative. I'm going to bring it to the top. It's going to become positive. I guess I should show that here. I can bring it to the top. It's going to become positive. And this is negative. If I move it to the bottom, it becomes positive. If I flip it, it's going to change the sign of the exponent. So that's just what I'm going to do. I'm going to get this 3 squared. I'm going to move this y to the 3 from the bottom to the top, and the exponent becomes positive. And then this x to the 6 goes to the bottom, and it becomes positive. And I could take this 3 squared and write it as 9, but it doesn't really matter too much. Did that help you out a little bit, Leeds? No worries. Did anybody else run into any issues when they were plugging through here? Page 713C. I'm going to assume that that's going to be the same as mine. 13A and C. A and C, there's those guys, for sure. All right, so 13A, I have a 2 and a 5. I can't do anything with that. And I have an A and a B, so I can't deal with any of those. I see I have this negative 4. If I want to make it positive, I could just rewrite this as 5b to the 6 over 2a cubed. And now that's all to the positive 4. So if I want to get rid of my negative exponent, make it positive, I take the reciprocal of everything. Now everything inside my bracket needs to receive the exponent of 4. And I'm going to multiply these, 2 to the 4, and then that's going to be 12 on the bottom. So I'm going to get 5 to the power of 4, b to the 6 times 4, 2 to the power of 4, a to the 3 times 4. I could probably have done that in one step. 5 to the 4, 6 times 4 is 24, 2 to the 4, and 3 and 4 is 12. 5 to the 4 and 2 to the 4 might simplify. If they can, you can just do that. 5 to the 4, what's that going to be? 5 times 5 is 25, times 5 is 125, times another 5. It's going to be 600 and something divided by 16. That might simplify further, but for now, we'll just leave it as that. Letter C. I really like C. A little bit tricky, but uses kind of all the exponent laws. All right, so I have this exponent of -3 on the outside, and I'm going to get rid of it. That's the first thing I'm going to do. I hate it when I have a negative exponent on the outside, so I'm going to flip everything. Doesn't matter if it's negative or positive, I'm going to flip it. I'm going to end up flipping things more than once because there'll be negative exponents inside and outside. Kind of two ways I can deal with this. I could write this as, I could multiply this -3 through if I wanted. I could do it that way. Or I could just flip everything. So -2x to the -4, y to the -2. That was my denominator. It's now my numerator. 5x to the -3, y to the -3. Now this is all to the power of +3. So I got rid of the negative exponent on the outside. Now I can simplify my x's and y's. The 2 and the 5, I can't simplify those, so they're just going to end up staying like they are. So -2 on the top. I'm going to have a 5 on the bottom. I have x to the -4 on the top, and I'm going to subtract -3 because I had a 3 on the bottom. And then I'm going to have y to the -2 on the top. And because I'm dividing, I'm going to subtract -3. And this is all to the power of 3 still. And again, this is just one way to do it. This isn't the right way. There's many, many ways of dealing with this. -2. -4 minus -3 is going to give me x to the -1. -2 minus -3 is going to give me y to the power of +1. This is all over 5, and it's all cubed. All right, now everything inside my brackets needs to get this exponent of 3. So I'm going to give it to everything. 2 is going to get it, this is going to get it, this is going to get it, and the 5 is going to get it. So I have -2 to the power of 3. I have x to the -1 times 3. I have y to the +1 times 3. And on the bottom, I have 5 to the power of 3. I'm going to just bring this back up here. -2 to the power of 3, I'm just going to leave it like that. X to the -1 times 3 is -3. Y to the 1 times 3 is +3. And then on the bottom, I have 5 to the power of 3. Now I can't write my answer with a negative exponent, so I need to bring this guy to the bottom to make it positive. So I'm going to have -2 to the power of 3. I have 5 to the power of 3 on the bottom. I'm going to bring the x to the bottom to make my exponent positive, and I had this y on the top, which was already positive. I could write this as -8y to the 3 over 125x3. That's likely how it's written in the answer. So there you have it. That is about all we have time for. I realize there's a lot of questions and they can get tricky. So even in the course, there are hints to these questions, especially 7. lesson 4, 2, and 3. So these kind of go through, show you steps of how to do those questions because there are lots of different ways to do them. So what's going to happen is this. Next class, we have a double block next day. It's like 9 till 11 on Thursday. Next class, I'll start with the first half. Any questions you might have on this stuff. If you guys don't have any questions, then I'm just going to move on to Unit 4. So the more questions you have, the more time I will spend dealing with Unit 3. Once all the questions are done, nobody has any further questions from Unit 3, I'll move on to Unit 4. So if we start at the beginning, nobody has questions, we're just moving on. If you guys ask questions for 2 hours and do the whole learning guide, that's fine too. So I'm going to expect that your learning guide is submitted on Thursday, and then you guys write the Unit 3 test before next Tuesday's class. So that gives you a week. Today's the 8th. That gives you to the 15th to write the test for Unit 3. Yay, double block, I know. Very exciting. So that's what I'll leave you guys with. Just a couple reminders. You guys have probably heard about this already. We have 2 field trips this week. On Wednesday, tomorrow, 10 to 11, we'll send out an email. You can log in online, go to the Cleveland Museum of Natural History, talking about some dinosaurs. And then on Thursday, we have a trip to the Military Museum. Military Museum on Thursday from 1 to 2. We're actually going to have class in Blackboard on Thursday for the double block, so you guys won't have to sign into the live feed next Thursday, just Blackboard. So I'll put up a note in Blackboard to just remind you guys. You'll figure it out pretty quickly anyways, but that's that. So everyone have a great afternoon, and we will see you in Blackboard on Thursday. Thanks.